Good evening, everybody. We have a partition problem. Let me write down what partition means here. We'll use 316. You can rewrite 316 as the sum of two natural numbers all kinds of ways. But I'll just go ahead and use the example 298 plus what, 18 maybe? Okay, so 298 is one part and 18 is the other part. Okay, so that would be an example of a partition. I think that's a little bit different than the usual meaning of partition, but I'm not sure. Okay, so anyway, that's an example of a partition, but notice it doesn't meet the condition that one part is divisible by 13 and the other part is divisible by 11. Okay, so we got to take care of that. Again, this is just an example. So this is always a nice, clever way to write it in terms of a single variable. 316 is equal to x plus 316 minus x. You can rewrite this in modular arithmetic form. Okay, and then this reads x is congruent to 0 mod 13. That means 13 divides x minus 0. And that another way of saying that is x is just a multiple of m, okay, where m is an integer. Okay, and so we can substitute this 13m right here, all right, right here where the x is. We can take x equals 13m and place it right here, is what we did on the very next line. Okay, now, so what we do at this stage of the problem is we reduce this mod 11 and we get 8 and 9. Let's see here. 9 is congruent to minus 13, right? 9 is definitely congruent to negative 13. Okay, and that's because 9 minus negative 13 is 22, right? So 9 and 22 is a multiple of 11, right? Okay. Then also, what about this 8? I think we can rewrite 316. We can write 316 as, let's see, the arithmetic here would be 316 is equal to 11. It's equal to 11 times 28, which is 308, right? That part right there, 11 times 28 is 308. And then we go plus 8 right here. Okay, plus 8. And see, folks, this 8 right here, this is a remainder. And you can think of congruence arithmetic as remainder arithmetic also. So that's where this 8 comes from that you see right here. Okay? Now, in this setting right here, there's only 10 possible remainders, namely 0 through 10. And it's not hard to see that m equals 4 satisfies this, okay? M equals 4. And you guys can verify that. It's not hard. It's tedious, but all you have to do is go through 11 cases. And turns out 4 works. That's because 4 times 9 is 36, and 36 plus 8 is 44, right? Again, 4 times 9 is 36, 36 plus 8 is 44, which is divisible by 11, right? So we get m equals 4. And so if m is equal to 4, right up here, if m is equal to 4, you would get x equals to 52, right? X is equal to 13 times 4. Equals 5, 2. Okay. Then right down here, very quickly, we'll see that 316 does partition into 52, which is a multiple of 13, and then plus 264, I believe. And y'all, there's a divisibility test here, but this is divisible by 11. Y'all might remember the divisibility test. You can go minus 4 plus 6 minus 2 gives you 0, and 11 divides 0. You can verify this. I'm not going to do it. This is a multiple of 11 right here. This is a multiple of 13. This is a multiple of 11. You guys can verify that. Anyway, that is the solution, and hope you enjoyed.